All right. So today is the May 23rd meeting of the Kubernetes Resource Management Work Group. We have two topics on today's agenda. We'll go in order. So Seth and/or Connor, do you want to go first a little bit on what you've been doing for CPU pinning?
Yeah, I guess the first thing to mention is that the proposal doc has been translated to and it's available for review on the Kubernetes community repository. So there's a PR called Add Proposal for CPU Manager. And yes, thank you for the link, Shimon. Yeah, any and all reviews and comments would be very welcome there. There are a couple of blank spots in the proposal that we still need to fill in, but I think there's plenty there to get a discussion going. As far as the item that's on the agenda, one requirement that was surfaced when we were staging the proposal doc is the need to potentially expand the CRI to allow CPU sets to be updated for containers. And so I think for that topic, I can turn it over to Seth and Shimon, who have both prepared PRs to scope out what that would look like. And they're up for review. The links are there in the document. So you two want to expand on that?
Hi, this is Simon speaking. So as Connor said, there are two pretty much similar pull requests or proposal on how to extend the CRI with the Docker update command. The difference between them is just basically in the approach on how much do we want to extend the CRI or leverage existing code. So they are more or less the same. The different only the implementation detail, but it's a good start, I think, to have a conversation on how much we want to do it and what would be the timeline to integrate it. Because as Connor mentioned, updating the CPU sets for the containers during the runtime will be probably very important piece of functionality that will be needed for the CPU manager. So from at least my perspective, it doesn't matter much which approach do we take. The one that Seth suggested, so extending the RPC call or utilizing the existing update runtime config call that's already there. So yeah. I'm good with both solutions.
So I had a couple questions, and maybe others knew this, but I didn't when I was catching up with Seth. Was like originally there was a period of time where I thought that Docker updates actually restarted the container process. It sounds like that might not be the case, but I'm curious if anyone has actually researched it back a certain number of Docker versions to know if that's true. Or maybe Renal, you know what the state of the world is on that?
I only tested one of the recent versions, and they do not restart any containers. What I found out is that it's basically a lib container write to the cgroup file system that can manipulate the for instance, CPU sets, but I didn't notice any restarts, but I used one of the latest Docker versions, so I have no idea how it would work with some old ones.
So Manon, do you know if I was mistaken? I thought one of the reasons vertical scaling on the container was that you couldn't resize running containers on certain Docker versions.
So I think there were some edge cases for the kernel memory limit. I'll have to check that, but otherwise I don't think there's anything there that would require a restart. So if there were a restart, Docker must be doing it. There's nothing in runc that is restarting the process. It's just updating the C groups.
Okay, but at least on like, I assume you guys were testing what, 112 plus, or what versions of Docker were you working at?
So yeah, I guess I can test it from our side and let you guys know.
Yeah, our versions of Docker was one definitely plus 12 or even more, I guess. I need to double check, but one of the reasons I try to update quite frequently. So.
And then I'm not sure how much everyone's following this call, but can you give a little bit of background on why you need to change the running containers existing CPU sets? And then what's the ramification of changing a running container CPU set for the performance of that container, and just how immediate is it affected upon?
Okay, so background on why that functionality is needed in the CRI?
Yeah, I'm not sure if, I mean, there's some new faces on this call. I'm not sure if everyone's following what we've been discussing for CPU pinning generally.
For sure. Okay. So part of the idea is that there would be a new component in the kubelet called the CPU manager, and it would ship with a few policies. And the policy that we've been focusing on in the proposal so far is it's called the static policy, which means that once a pod is admitted, the CPU manager is consulted to give a decision on what the CPU set for each container for that pod will be. And that decision holds for the lifetime of the container. And so static refers to the fact that that allocation won't change for the lifetime of the container. And that's in contrast to a different policy that's planned called the dynamic policy. So for now, we can just talk about the static policy. And okay, so initially when a pod lands, say if it has a burstable QoS class or best effort QoS class, we want it to be able to run on all of the available cores so that we get maximum CPU throughput for the jobs on that node. But meanwhile, if there's a guaranteed pod that lands that has containers that request integer numbers of CPUs, we want to improve their performance, specifically with respect to CPU CFS scheduler latency and cache affinity by constraining them to a smaller number of cores and then ensuring that they fulfill their CPU quota only using those cores. And so to do that, we have to move the non-exclusively allocated containers off of those cores when that guaranteed pod lands on the node. And since we don't know in general all of the pods that will get bound to a node a priori, we have to do it in a more reactive way, such that when the pod gets bound, we have to shuffle we call them the shared pool of cores in the proposal. So essentially, we have to make a hole for the containers that are going to utilize those exclusively allocated cores. Does that explanation make sense to people on the line? I guess we can just feel free to ask questions if that wasn't clear.
No, I thought it was a good summary. So as for timing, I see this isn't going to get into Cube 1.7, but hopefully we can get this in Cube 1.8. Like, ideally, I'd like it if both Seth and Simon could coalesce on a single preferred proposal. And then I think at this point we could probably just transfer this discussion to sig-node on the CRI mechanics. I need you to
really, the only difference between our proposals is one tries to use an existing CRI method called update runtime config that we basically, it's meant to update the runtime itself, but in this case we can pass it a container ID and an updated container config and use it that way. But in my opinion, that's using the method for a purpose that its name doesn't imply. So my proposal just makes a separate method for that, specifically for the purpose of updating container resources. So that's pretty much what the difference is. And then I've been looking at the Docker engine API, and update was introduced in 1.22, which correlates to Docker version 1.10. So I think it should work on any Docker version 1.10 or higher.
Yeah, as I mentioned before, I'm good with both proposals. So we can close mine and work on your set to get it merged as soon as possible. I'm good with both approaches.
Okay. So any other topics you want to bring up on this, or I assume we're going to do a deeper dive on the CPU pinning proposal in a future meeting.
Yeah, should we queue it up for next week? It's just the proposal was only submitted last night, so
yeah, I haven't had a chance to read it all, so I'm good with next week if you guys want to queue it up for then.
Sure. Just on your previous question about Docker support, do we have a matrix of versions that need to work with Kube?
We do, and it's usually n-3.
Okay.
Yeah, we don't give a prescribed Docker version anymore in the community, so I think Google might be still running Docker 1.11. I think they want to move to a later version. I'm not sure. Like Red Hat runs 1.12, so I don't know. We're not as prescribed on the best version to run. It's just n-3. I think right now is our stance. So if it's 1.10, I think we're okay. All right. So if no other topics on this one, and thanks Seth and Connor for continuing to, and everyone else for continuing to push the CPU pinning discussion forward. We can transition to the second topic from Ram on the cache partitioning.
Thank you, Derek. Yeah, this is from me and Mrunal. So should I share my screen?
That would be probably more interesting for anyone on YouTube that might watch this in the future. So yeah, go ahead.
I couldn't. Yeah, I couldn't figure out an easy way to share. It's not built into Zoom. So if everybody's okay, I can just run through the Google document.
So I'll share my screen then.
Okay. Oh, perfect. Yeah, somehow I don't know why it's not.
Just to confirm, can people see the document in front of them?
Yes.
Okay.
Excellent. Thank you. So yeah. So is it part of Zoom, or where do I see it? Just in the Zoom. It's okay. I somehow am unable to. Oh, sorry. Mine went to minimize for some weird reason. Okay, I got it. Thank you, Derek. Okay, got it. So,
So are you going to be able to share now, Ram, or?
No, I think please go ahead. Let's keep it. I'm still trying to figure this out. I think so. I don't want to keep people waiting. Go ahead, share it. So, excellent. So what is this? So, we very briefly talked about it during the face-to-face meeting. It's all about, what can we do to minimize application tail latency? It's all around, advanced keywords, right? So the goal is to essentially enhance performance of latency-sensitive applications in Kubernetes. One is minimizing tail latency by, removing any impact from shared resources from other containers. Now, number two is just along with it, or improve overall application throughput. So essentially, there are two parts to it. One is essentially the key is that what you would like to do is we want to isolate the background applications such as garbage collectors or any large file transfer, anything which is really a background task, to the region of the cache, especially the last level cache, right? Arguably, you can say, hey, as long as like the previous proposals we discussed, if we can isolate the low latency task to specific, cores, right? So then, all is good. But then the problem is the last level cache is a shared resource across all tasks, right? And that's the point of contention. And again, here essentially we are utilizing a hardware capability based on Intel RDT, where the goal is to start simple. Essentially, what we are doing is, trying to associate all the background containers or specific p threads within them. For example, if you take a Java application, it's one container, but then there are several p threads. Only certain of those p threads are really these background type of jobs, so garbage collection tasks, right? Rest are, the application threads. You don't want to kind of isolate them. So essentially, keep it simple. Just associate the background tasks to a partition for a start, but rest of the system just use the entire LLC, right? Because if you try to put them onto nail them to specific regions of LLC, then there are things which are hard to describe from an application perspective. What all is going to happen? So jail the background task for a start. Keep it simple. Rest of it use the entire LLC, right? And this essentially, in terms of a JVM context and the value proposition, there is a detailed proposal including proof of concept results, right? I think many of you might have seen this before. It's a detailed document, so kindly go through it. So it even goes and says, hey, if I partition the garbage collection task, how is it going to change the time, right? Basically, assign different partitions of the GC thread to, from size varying, the full cache to 10% of the cache in 1%. So behavior on how long it takes to complete the garbage collection thread. So now, essentially and also a little bit more on customer use cases. So essentially at Dell, we did a nice proof of concept with enterprise customer. So there we were not using it in a container context, but more of the VM context. So what we did was essentially on a single socket, there were both search applications in one VM, and other was the background big data type of transactions happening, right? So they basically it was just background IoT inventory management. So what's happening. So there with that. What we really did was just jail the big data task to a region of the cache, right? And that way, what happened was we were able to maximize the overall utilization, but still not impact the search application, right? We were able to guarantee the latency. That was a proof of concept we did with enterprise. It was very successful. So this is kind of leveraging this model in Kubernetes, and also not just the ecosystem, and where we see application specific opportunities around such as JVM, where we do, it's not just about a simple assignment of the entire container to the partition, but being even more selective. Only certain background threads within the container to the partition. Right? And again, we have to remember that the number of partitions are limited. And for example, if we take the latest Intel numbers, they're just around 16. That's it. That's the number, and it's a shared resource, and it's a constrained resource. The size is around megabytes. We're talking like 20 megabytes, 40 megabytes. That's it, and it's shared across several tasks. And also further, a little bit of context about Intel resource control is kind of an internal discussion with Mrunal, I think, our Red Hat team. So one of the biggest things we did when this work was started by Intel with Google and Dell was that what he realized was along the journey, you cannot use C groups for it. The simple reason is C groups is a built-in inheritance property, right? So basically, when you fork a process, it inherits the parent's relationship in terms of managing all the resources. And in this case, it simply doesn't work because we want to construct. We are not following any hierarchical rules. We're deciding these are the set of tasks we want to associate with these partitions, right? Arbitrarily, and that was one of the key reasons we went ahead with the resource control file system model. Basically a new sysfs file system component, right? Which is a key behind driving this. So Mrinal, you want to add anything else on that? So we went.
No, yeah, this sounds good so far. Yeah, just go ahead.
So now diving down to, I mean, at least a high level implementation summary on what all the steps that would happen. The first is we envisage the cache partition be created by the cloud administrator. I mean, of course, this feature is dependent on Intel RDT cache. I mean, it's possible only in those nodes which support it, right? And cache partitions are made available to VMs. I mean, if you're doing bare metal, the steps will be not present, right? And in this case, when you're, I mean, basically, if this feature is running on VMs, what we expect is mega VM type, where the VM should occupy the entire socket or sockets. I mean, and then now, and the entire partition is handed out that to the, the container Kubernetes. That's the only way it will work in a VM landscape meaningfully. And cache partitions are made available to kubelet. And essentially, the next step is also exposing the cache partitions to an app through, for example, through a standardized container spec through an environment variable. So I pulled up an example. So the microservices deployment example where the environment variables are specifically passed to a Java application. As you can see, you scroll down, Java ups the value, right? I mean, basically the value for different use the G1G, the latest algorithm, or I think the XMS is probably around the heap size. There are so many parameters you can pass, but the bottom line is, you can pass environment variables. So our hope is we can use that framework to pass the relevant cache partition, right, to the app.
Can I ask a question here? I guess I've had.
Sure.
So when you basically said it's exposed to a containerized part of your container spec, so is this an actual resource that you would expect to appear in a container's resource requirements and with like a literal number next to it, like I want this much of the cache, or I guess, and do you imagine that the node would advertise some size for this? So like, what is the way that the node would push this?
So good question, Derek. The interesting part is this is really a constrained resource. So, I mean, you cannot really say that, hey, so for example, the best that would make sense is percentage, but I mean, to me, at least for a start, it should be so simple that partitions are even that is pre-created, right? What the size should be, right? At least a starting point, and then just pass the partition ID or something like that, or some form of notation, because the percentage means then you give, I mean, that's the next level where you add more dynamism. That means, and then you also have some tunability around that, right? So the simple is just, I mean, saying, hey, you belong to this partition. I mean, you can use this partition, add your threads to the partition, as simple as that.
So if I was to relate this back to some of the work that Connor and Seth were talking about, like is a guaranteed pod the only pod that makes sense to be using this feature?
No, rather the other way. So for example, let us say there is a guaranteed pod and the best effort pod running, right? So the goal is to make sure the guaranteed pod is absolutely guaranteed everything with respect to resources, including the last level cache, can maintain the application, can realize the the SLOs around tail latency. It said, hey, I mean, in Kubernetes, thou shall not violate this latency. I mean, SLAs, right? So now what you do is you take the background task and then now you start jailing the garbage collection type of task in the background containers to this partition. The other way, actually.
I guess what I'm trying to tease out is like the unspoken requirements between steps 3 and 4 here, right? Where like step 4 is giving one potential way that the cache partition is consumed in a sample JVM app by setting some nvar tunables. But like similar to huge pages, as another example that we set with JVM stuff, or even when you size your heap, like I would expect those nvars to be pulled from the downward API on the actual container's resource requests. And so I'm just trying to understand, like, when you make the cache partition available to the kubelet, how does the kubelet actually fairly share or allocate those to the individual pods independent of what the container spec said? Like an MVAR is opaque largely to the kubelet. But I think that's a detail we need to kind of tease out. And I have to read through your proposal in more detail to make sure maybe it'll jump out to me. But I think the current contract proposed here is probably not sufficient.
Got you. Brunel, any thoughts? You have some.
I think So like the kubelet could divide that into like static partitions, and then it'll have a certain number of static partitions that it can hand out, and those partitions would be of different size. And we'll have to figure out how exactly pods could request those.
Okay, but as long as you guys like understand that, like largely the kubelet's going to be treating MVARs opaquely, and the MVAR value should be pulled from some node API, and like the kubelet's only probably going to isolate on things that are in the resource requirements section of the container or pod or somewhere else. We just need to make sure that if the kubelet needs to isolate something, it's not opaque. All right,
so the valid point, Derek, and we have also not got to the level of the expanded proposal. This still just wanted to make sure the use case, everything is all coming together.
Somewhere between 3 and 4, we need to give more detail. But with
absolutely,
that, we can move to 5.
So yeah, I think the 5 is the one which is like contentious, because I can talk about it, Ramki, if you don't mind. So
sure, please go ahead. Yeah,
so if I talked with Ramki, and he tested it out and confirmed as well. So the way this works is, whenever the container process is forking any other process, it doesn't get added to this partition automatically. So, and it wouldn't want all of them to be added automatically as well. So we need a way for the process to communicate up the stack as required to add a new task to the cache partition. So as far as I understand, there's nothing similar to that right now. So the way I imagine it would work at minimum is, we'll need to expose some kind of an FD or a pipe into the container process. It will have to be standardized in OCI, and then the container process knows that I can send PIDs over here and ask those to be added to the cache partition. And then optionally, if we need further validation, then it can go back to the kubelet, and then kubelet can decide whether to reject or accept that request. And if the request is accepted, then it comes back to the CRI, maybe through the update CRI API, and says, hey, you can add this task to this cache partition. So I don't know whether this is allowed, or there's any other similar feature that works in Kube today.
Yeah, I don't have a good parallel in mind.
So do you know, like,
so the issue is you don't want to require to run privileged in order to get this to work, correct?
Yes, exactly. And the container should be able to dynamically add more processes to the partition. So one thing that could be done is, if you don't want to go all the way back up to the kubelet, you can just say that, hey, this process can add whatever tasks it wants to, and then it can just request this to the shim, the monitor process, and monitor process can automatically add it. Then it doesn't have to do the whole round tripping up to the kubelet. That will make it simpler, but then there is no authorization as such on what kind of, you trust the container to make the right decisions and add the right processes.
Yeah, I'm trying to even think about like any areas where we would have a container speaking back to the kubelet that launched it right now.
Would it be okay to just do it progressively? So you could have some sort of a reconciliation loop that just looks at all the PIDs inside the C group and adds them to the partition.
Well, I mean, yeah, that could be done, or we can just restrict this to the monitor process. Like, so, like
you didn't want this on every PID in that C group, right?
You wouldn't, you wouldn't. You would want a process to tell you which ones you want. So hence a pipe is better.
That's what I was getting at.
Yeah. So you would want the process to request what it once had it.
I mean,
so this the task-based strategy that's implemented in resource control is going to have slightly different performance characteristics depending on the generation of the CPU. So like from Broadwell to Skylake, for example, the caching strategy is not the same. And so you might not get the effect that you expect to get. And for that reason, it might make sense to do cache partitions based on core, which you can also do in the resource control file system, versus basing it on task ID. It's just something to think about. I think we'll have to do some experiments to make sure it does what you want.
No, absolutely, Connor, and also that's exactly right. I think at least for a start, it should all be based on, basically the node selector, right? I mean, absolutely, and this feature will evolve over several generations, and correct.
So if we go with that approach, then there's no need for the container to talk back and request anything. Is that correct, Connor, Ramki?
So the only thing is who is so is there then are you passing a pre-authorization then?
Yeah.
How will that be passed to the task, the pre-authorization? What's the mechanism?
So I don't know the details of how what Connor said would work. So we'll have to take a look. But I was just asking that if we go with that approach, then can we get rid of the requirement that the process needs to ask and add tasks dynamically? So then there's no upward communication required.
I don't think it solves that problem that you guys raised. To me, just looking at this, like most of the complexity really comes from the requirement for sub-container level scheduling. So you're looking at some sort of like thread level. I mean, if you do the cache partitions based on the cores that the tasks are running on, then you still have the same problem, right? You have to communicate, okay, I want the garbage collector thread to run over on these cores. But I guess, if we just did container level partitions, then that would avoid that complexity as a first step. You could start by herding best effort containers and then herding burstable containers. But going down to the thread level, I think you open up a big can of worms no matter what you do.
Yeah, like I think practically we should be able to signal which CPUs you're running on as a part of the CPU manager work, but asking the kubebot then to manage threads within your container is kind of a mental set of gymnastics I haven't prepared to do. Maybe I haven't stretched for it yet.
One thing that you can do. One thing you can do that we did in POCs was essentially the first thing that Derek said, which is to communicate down using like an environment variable. And at that point, kubebot's hands off. And at that point, it's up to the application to move itself around. So
yeah, exactly. And I think that works. And then kubelet doesn't need to be involved at all. Then the application can make smart decisions and it can just talk to the runtime. So as like a runtime,
it needs to be privileged though, right?
No, not really, right? It doesn't need to be privileged. So if we pass down an FD, it should be able to just write the bits to those FDs and the runtime can just add them on its behalf.
Okay.
Yeah. So we can implement that in runC or the monitor process. That should be straightforward.
But you're basically adding just a a shim over the syscall interface for the container.
Yes. So and this shim needs to exist for like any runtime that is run C based. So like Containerd, Docker, CRI-O, all of these have monitoring processes, and we can add that functionality to the monitoring process, and define some kind of standardization in the OCI spec that, hey, this is the FD that needs to be passed over which you communicate your task IDs.
Is there precedent for that? Sorry, I might not know enough about the spec, but then you have an application that really only works inside of a container and won't run on regular Linux.
No, there is no precedent for such a requirement before.
No. Yeah, I think the key is that, the application is running as non-privileged, right? And now how do we make sure that, hey, it can add selective threads to something like a privileged sysfs, right? How do you make it happen in this ecosystem? That's the precise problem we're trying to solve here, right? And of course, like you said, Connor, this is completely independent of any of this. This problem will exist even in a simple Linux system if you try to accomplish this. Because, all the time, your general application has to be running as non-privileged, and then from a security standpoint, but yet you want to make sure that certain threads or background threads want to be associated with certain, partitions or other type of hardware features.
I guess what I'm wondering is like, if we're starting to call out needs that have the kubelet having to do like thread level scheduling like this, like could we look at what would be the possibility of solving this another way, which would be like having a daemon set pod that took on that responsibility versus having the kubelet have to have that responsibility. So anywhere where you want, I assume this is a JVM, anywhere where you want this to happen with your JVM, make sure it's co-located with a daemon set pod that can run with higher privileges. Maybe that's what's doing the monitoring.
So actually, I just took a look at sorry, I didn't mean to
that's fine.
Run you over, Derek.
I guess what I'm wondering is like, I'd be curious to evaluate that as an alternative to anything that starts to sound like a little bit like step 5 here.
So I was looking at the syscall docs for sched set affinity. And so if we did some sort of a CPU based cache partition scheme, that PID can set its own affinity for threads that it starts without having to be a privilege. So that could be one way around it.
Yeah, if we have such a syscall, that'll be perfect.
Yep.
So maybe start from there. Go talk to the kernel guys and see what they think.
No, it exists.
No,
You
can
just call it.
So what is interesting is I went to this specific sysfs discussion even with the kernel team in the past also, now recently from Intel. So basically sysfs is what it is. Of course, yeah, like you said, Connor, that's cool actually, the thread case, the thread affinity. But sysfs, I think, yeah, this is how it's going to be, right, from a kernel standpoint. Only a privileged user can add anything to it. But I guess getting back to sysfs and partitions, it can be, I think, looks like we have something in the direction of just a download call with authorization, which is solvable. You don't need to go back to kubelet, right? Right, Pranal? It's a possibility, right? You don't need to really go back to.
Yeah, we don't need to go back to the kubelet. The runtime can take care of it. Either ways, whether you want to add all of them or you want to add selective bits, both can be handled by the runtime.
Which sounds like maybe a simple starting point, right? At least making progress. Well, I think Derek also brought up a good point, how do you think about the long-term strategy, right?
Yeah, so So yeah, that thing is like kubelet versus daemon set. But I still think that if we care about adding like specific task IDs, then we would need some kind of standardization in OCI. So
That's correct.
So do we want to wrap up the rest of this talk, or do you want?
Oh yeah, rest is basically all around statistics. So this lists the elaborate set of statistics which due course needs to happen to leverage this feature. The first is we need to use per stat to determine cache hits and misses, right? Basically, we're jailing the background apps. We need to figure out what the heck is happening, right? And basically, if you're doing more fine-grained monitoring, then we need to fit that in the kubelet monitoring budget. The next very related feature from an Intel RDT family is the cache monitoring. So basically, now your partition, you've created a cache partition, so you need to monitor it periodically, and then again, this needs to fit in the kubelet budget. Then what is very interesting is that because you're partitioning the cache, it's very likely that the memory bandwidth usage may surge, because what was happening was there was a cache in between fielding that application that was doing intense data copy. So now, as we progress, it's also important to monitor the memory bandwidth, especially when we are doing cache partition and need to fit into the kubelet budget. And there is also another feature from Intel called memory bandwidth allocation, which is for limiting memory bandwidth usage. It's even super advanced. But as we do, I think these steps, CMT and MBM, then something to think about, right? To avoid any kind of power surges, all those, as we progress along. And the last but not least, this is super advanced. Again, something to think about as we progress is potentially this could progress to a smarter scheduling type of ideas. So basically, right now, the way the apps work is the garbage collection task can happen anytime. Basically, it is not something which is manually scheduled, right? So what if this is some kind of conveyed, app notifies the kubelet, right? Basically, right now, if you look at a JVM, some kind of predictive analytics and saying, hey, how long approximately this garbage collection event is going to take. And what if we notified kubelet, through kubelet, this is notified to the kube scheduler for doing overall smarter scheduling. If this is going to take like approximately 5 seconds, right? Can be smart about what you're scheduling with 5 seconds and try to avoid eviction. Again, advanced topic only when you actually make progress and build a story around the basics.
Okay. Well, I know myself going to take some time reading through some of the other linked documents and digesting some of this. So I know you were also going to present to sig-node, which is probably a good thing. Trying to think if there's any other next steps. So like the primary applications that consume this, it seems like there's a lot of JVM use cases. Are there other like application scenarios that people had in mind?
So basically, JVM is very, very concrete in terms of specific threads within a container. But in general, anything which is like, for example, a simple, if you're doing a file transfer, right? Then obviously, which is not deadline bound, then that's a good use case. And beyond that, even in the NFV case, when we're going towards 5G, I've been in several customer discussions where this gets very critical, especially when you're doing network slicing, right? The goal is to make sure these different slices are not interfering with each other. You have a high priority slice for serving, for example, a connected car type of use case, right? And then the next task, the normal. And these are supposed to be able to coexistable on the same physical infrastructure. That is also a very good use case on the NFV front.
Okay. All right.
But the immediate spot on is the JVM one is like, and the good thing is also figured out some ways to kind of remove any, at least for now, remove any JVM dependencies. That means it should work with JDK 8, which is one which is basically made available to customers now. JDK 9 is still not available.
Then from like a prioritization standpoint, just out of curiosity, like anybody who's looking at getting the cache partition support here, what other, like there must be a whole host of other table stake things that are required to make Cube a viable platform for them. This can't be like requirement number one. So I'm assuming like any of the CPU pinning work, that's probably a higher priority for this target demographic than cache partitioning. Like I'm just wondering, like as a project, as we prioritize stuff, is this where would that fall? Where would this feature fall relative to say the other resource management topics we've discussed?
So to me, I think this can happen in parallel, because the reason is, agreed that the eviction, the pinning, all that is super important. But it's kind of saying, as we do this, if a simple thing as an LLC is not looked at, then there's no holistic solution. You solve that problem, but then because the LLC work is not complete, it comes and hurts you in a holistic angle. Because this will really, from what I've seen, this really kills all the work, QoS work you did do on the top around pinning to course everything, right? That's what we found working with the enterprise customer back at Dell. I mean, you can try all this. We tried all that. Then we found, oh my God, this is the best way to manage that situation for latency sensitive apps. So basically, this is a key part of the holistic solution. Okay. So I would vote for parallel progress.
Okay, that's good to know.
And the good thing is also, I recall I was talking to Vish about it, and he did confirm that Google is using this internally inside Bog in a very simple form, something like this. Just create a few static partitions and manage them in a simple way, but they have found it very effective for latency sensitive applications.
Okay. I appreciate you guys putting us together, and maybe in a few weeks' time, Renal and Ram, after you explore what the boundaries are with the OCI, or maybe get a little more detail on step 5, we can try to get a more formalized proposal out.
Yeah, sure. I think if maybe we can talk about this one more time. If there are no other alternatives, then I'll start an upstream discussion on OCI to get this added.
Okay. Let's see, so that rounds up this set of known topics for today. Are there any other additional topics that people want to bring up in today's meeting? Otherwise, we can adjourn for next week, when it sounds like we will do a deeper dive on the CPU pinning proposal. And just for awareness, I think we're also trying to explore doing a prototype around resource classes in the next 3 weeks or so. So hopefully that'll be on the agenda soon. But if folks have other topics that they want to bring up for discussion in the near to midterm, please speak up and we'll get it on the list.
Was resource classes something that's, do you mean like the proposal over the next few weeks, or like a POC plus proposal?
So if you recall, we left the face-to-face saying, like, we think resource classes seems like a good concept, but we're not really sure if it'll work.
Okay.
And so two folks here at Red Hat are trying to see if it will actually work from a scheduling standpoint. So when you have a resource class resource in your pod spec, can the scheduler actually record properly in the node fits type predicate checks that that resource, when expanded out to an individual device on a node that match that field selector, like, does the scheduler get confused or not? And so we're just trying to figure out, like, given what's been discussed thus far, where will this break down so that we can inform a better proposal and know if it's going to work at all. So we're just trying to get a prototype in place.
Okay, cool.
That felt like step 1 to unblocking a lot of other potential related work around maybe huge pages and then any other device work. So anyway, that's that. So look for that in the next few weeks.
Great. And then the other thing was, I noted in the resource management work group community PR, there was mention of creating a new mailing list for this group. Is that something that we're going to pursue, or are we still collecting opinions on it?
Honestly, I just wanted that PR merged because it describes how we've been working for the last few months. And then we can come back to getting the mailing list stuff figured out. I'm fine getting a new list if we want to go that route. That's perfectly fine for me. I need Sarah to get me the list. So I don't know if she's responded to that PR yet with any details. So, but yeah. Anyway, any other questions? All right. Thanks, everyone. And we'll look to get this uploaded to YouTube tomorrow for folks who did not attend. And I'll talk to y'all next week. Bye.
Thank you, Brett. So,
Thank you.
Brunal,
Bye.